So to start off our discussion of perfect competition, we're going to talk about the market characteristics, meaning how do you know a market is a perfectly competitive one? So first, it has a standardized or homogeneous product. It's just a fancy way of saying that there is no quality difference among the goods, either real or perceived. So in fact, these goods are almost indistinguishable for another person. So what we're not talking about with perfect competition is something like smartphones. If you were to put a bunch of different smartphones in a basket, mix it up, you could then still separate which ones were made by Apple, which ones were made by the different Android carrier or producers, and even within those specific ones. So which one's a Google phone, which one's a Samsung, all of that you would be able to tell. However, if you were to take a bunch of different farmers' corn, all the same corn, put it in a basket, shake it up, then you wouldn't be able to figure out what ear came from what farm unless there is actually a quality difference. So this perfect competition almost never happens in reality because most of the time there's a little something that lets you tell the difference between the quality. But a lot of firms do act as if they were perfectly competitive. What we mean by they act this way, we'll cover in the coming slides. So here, buyers are willing to switch from one product to another for a lower price. Right? Because they're identical, you wouldn't pay more. So think again back to farmers at a farmer's market. If every farmer is selling their corn for $1 an ear and one farmer is selling their corn for $2 an ear, he's not going to sell any corn as long as those other corn farmers still have corn. Right? Again, we're talking about the same product. So it can't be that one is organic or they're different types of corn. They're all the same type of corn. And therefore, you can't be the farmer charging more than all the other farmers and expect people to pay it. The second characteristic of a perfectly competitive firm is that each buyer or seller must constitute of a small fraction of the overall market. This means that no individual buyer or seller has influence over the market price. This is called a price takers. Again, think back to our corn farming example and at a farmer's market. No one farmer can affect or choose the price of corn. They show up, they see what other people are selling it for. They might have to make adjustments if everyone is selling it too cheap or too expensive. So think of this as an ongoing farmer's market. They know about what the demand looks like. When they show up and see what the supply looks like, they charge a price to where they all sell out, but make as much possible money while selling out as well. So here, again, there's going to be many different farmers producing the same identical corn. And if one tries to raise the price when there's no need to, meaning when everyone else isn't raising their price, they're not selling out, none of that, then they're going to sell none of their corn. Since perfectly competitive producers can only sell at the market price and not a penny more, that means their demand for a single producer, so just one, not the market, is in a perfectly competitive market is going to be perfectly elastic at the market price. So that means if we have a situation like this where here's our market, there's some demand for corn, there's some supply of corn, they show up to the farmer's market, find out this is going to be the price of corn, That means for a specific farmer, so their individual one, their demand for their specific corn is just that price P star. So if they charge more, they won't sell any. They could charge less, but then they'd still sell out by charging P star, so there's no desire to charge less. So their little marginal cost says we should set that equal and sell. Again, if you're wondering where all of that came from, let's give a more formalized version. So every firm's goal, no matter whether it's a perfectly competitive firm or a monopoly or anything in between, is to maximize profits. And profits is the difference between total revenue and total cost. Total cost is like what we talked about last time, all your fixed and variable costs put together. Total revenue is your price times your quantity sold. And so, because that's the goal for all firms seek to maximize profits and therefore look for the point where marginal revenue equals marginal cost. So this right here is incredibly important. It's going to be true for any type of profit maximizing firm, which are the only types that we're going to talk about in this course. We needed another course to talk about it. And so this applies everywhere. If you're going to take away one thing from this entire video, it should be that relationship right there. Okay, so that's all firms. Competitive markets, however, have a constant price, specifically this P star price. Right? That's what's giving that perfectly elastic demand. And because they have a constant price, their price is the same as marginal revenue. Every time they sell one more ear of corn, they get whatever the price of corn is. Whether it's the first ear or the 100th ear, they get that. That's not going to be the case for all market structures, but that is for perfectly competitive. And so because price is the same thing as marginal revenue and it's a constant number here, for a competitive market, again, only for perfect competition, you can substitute in price in place of the marginal revenue and just say that they look for where price equals marginal cost, which is where this dot over here in our graph came from. They looked for where P star intersects their marginal cost curve, and they get that. That Q unit right there tells them how much they should produce. But we need to put this in a bigger scale and relate it back to our cost curves, which we'll do next. So to draw a complete picture of what's happening in a perfectly competitive firm as they make their production decisions, first you have to draw the market in order to get the equilibrium. Specifically, you want the equilibrium price so that you can get the market price. We did that in the previous slide and we got P star, at least that's what we called it there. And this price from the market equilibrium becomes the price, or the marginal revenue curve, excuse me, for a single producer, because that is the only price that they can charge. And so in order to see how they should produce, again, we know that their goal is going to be to set price equal to marginal cost, because everyone's goal is to set marginal revenue equal to marginal cost, and they have a constant marginal revenue at price. So let's sketch out our cost curves and talk about some areas here. So from last time, we learned that there's technically a little hook down at the bottom of marginal cost, even though we don't often draw it. We're going to add average variable cost down here. Its minimum is where it intersects marginal cost, and then it goes up from either point from there. Other than that, it doesn't matter exactly where you put it. Average total cost does the same thing, but since it's total cost, it should be a higher point on the marginal cost curve. So that is a very quick, rough sketch of what we're looking at here. So in general, if we want to know how someone might choose a quantity Q, they're going to choose the output where their price is equal to their marginal cost. So they follow whatever price it is, whatever price is on this axis, over to their marginal cost curve and read down. So we're going to look at several different regions of this graph in a moment, but just finishing at our notes here. So you follow the price curve over to the marginal cost, and then you go down to get your quantity. So before we start looking at the specific regions, I'm going to mark off 2 special points, and we'll come to why they're special towards the end of this slide. So first, the point where average total cost intersects marginal cost. I'm going to call this P3. Why I'm calling it P3 will hopefully be obvious in a minute, but P3. And then I'm going to call this point where average variable cost intersects marginal cost P1. Okay. So and they'll have corresponding quantities of Q1 and Q3, just in case we need them. Okay. So now we're going to look at our regions. Our first region is at a price above P3. So any price above that P3, I'm going to put my P4 here. And so we make a little dotted line. And it told us on the previous slide that we should make our decision where price equals marginal cost. So if this is a perfectly competitive firm, they're going to look for where that price is equal to their marginal cost, and this tells them how much to produce. Also, the average total cost tells us how much it costs on average to produce it. So remember, average total cost is total cost divided by Q. So if we want to find our total cost, we could take average total cost, our per unit cost, multiply it times the number of units, and that gives us our total cost. So that means if we trace back over here, this is our average total cost at price 4, right here. So our total revenue is price times quantity, which is going to be this big rectangle, right? This is our total revenue. Our total cost is going to be here. It's the average total cost times the number of quantity. So our profit is the difference between the green rectangle and the red rectangle. So that means here they're making a profit of this amount because that's the difference between the green and the red. Okay. So in this P4 region, they're at a place where they're making positive profits. So if this was your company, you'd be pretty happy, because here when we talk about profits, that's not necessarily the same thing as when you talk about it in an accounting class or some other class. We are talking economic profits, because economic costs include opportunity cost. So they're being compensated for their time, effort, and abilities and whatever they've invested. However, positive profit says they're getting extra on top of that. So that is a great place to be. At this place, you don't have an incentive to do more or less, and so you just have these positive profits. Specifically, your profits are equal to the difference between your price and your average total cost at the amount you're producing times the amount you produce. So that's the area of the profits if you needed to calculate it. It's also that shaded green region over to the right. Okay. So we'll come back to P3, but we need to insert a P2. So we'll put it somewhere in the middle of P3 and P1, just so my lines aren't too close together. So we take P2 over to our marginal cost, and that tells us how much to produce. Get rid of some of these green lines too. There we go. All right. So that's how many we should produce, if we should produce at all. If you look at Q2, you can read up and get the amount of the average total cost at that. It just so happens that our average total cost at 2, it's kind of smushed in there. It's just barely below with the sketch I graphed. Yours might look a little different. And the average variable cost at that price is down here. So if we're at a region where our price is between the P3 and P2, we're now at a place where our price is greater than our average variable cost, but it's less than our average total cost. So that tells us, since price is less than average total cost, it tells us that per unit, it costs us more to produce the unit than we can sell it for. That's not great. That means we have losses or negative profits. However, it's important to consider the variable cost because that tells you per unit, right? Part of our costs are fixed, and whether we make 0 or we make some, we have to pay our fixed costs. So if we can cover our average variable cost, that means you can, when you sell the item, you make enough money to pay for your workers and your raw materials and your electricity bill and your water bill and all of those things, and a little extra to help pay off your building lease. So it's not a great place to be, but it's not terrible. So even though there's negative profits, people are going to stay open, at least in the short run. Now, when that building lease comes up and it's no longer a fixed cost, then they might want to do something about it. But for now, they're just going to go ahead and accept it. And then let's talk about our last area. So we've done above P3, between P1 and P3. We need to talk about below here. I'll call it P0. If you should produce, you should still produce where your price equals your marginal cost, which is right there. Okay, so that's what you should do if you're going to produce. At this point, we can see our variable costs are here, and our average total costs are probably somewhere up here if we were to continue our line. Okay, so we're at a place now where your price is less than your average total cost, so you have negative profits or losses. Either way is an okay thing to call them. So we have negative profits, but we also have our average variable cost that's above our price, right? It costs us up here at this red point how much, or that amount to make each unit. Down here is the price that you can sell it for. So in this scenario, it now costs you more to pay a worker and buy the raw materials to make something than you can sell it for. So it makes no sense to stay open in the short run. So if this is where the business is, they should close immediately. So the decision to stay open or close is separate from whether they're making profits or losses in the short term, right? Because sometimes a little loss is bigger than a lot of a loss. So when you go back to the cost curve example from the last section, you'll have a chance to see some numbers again and be able to compare how much it would cost them to stay open and produce versus how much it's going to cost them or what their profit looks like. Excuse me, I've been saying costs. I should be saying profits. So what their profits look like at that point. All right, so our graph is a little messy. I'm going to try and do a little bit of cleaning up of these labels. Okay, that's a little better. So we've found that above P3, you make profits. And below P3, you have losses or negative profits. So that must mean at P3 you have 0 profits. So our 0 profit price in this graph is P3. In all graphs, it will be where marginal costs intersects average total cost. So, or the minimum of the average total cost curve. So your 0 profit price is going to be this point down here. Okay? So that is the profit decision, which is separate from the stay open or shut decision. So this price here, P3, above that price, you're going to stay open, at least in the short run. And below that price, you're going to want to close immediately. So that means P1 is your minimum operating price. That is also the same as where the marginal cost intersects the average variable cost. So in the short run to stay open, it's enough just to be able to pay for your workers and your raw materials. However, profits require you to also be able to pay your fixed costs. So this is our short run picture, and those are some pretty important regions. So P3 is our 0 profit price, meaning anywhere above it you make profits, below it you don't. P1 is your minimum operating price, so any price above P1 you're going to want to stay open, even if you have losses, and below P1 you're going to want to close. So that picture is all about the short run, what you're going to do today, not what you could plan to do 5-10 years into the future. So the key difference between the long run and the short run is the fact that there's no fixed costs in the long run, because you can move to a different location, you can expand your facility, you can sell off part of your facility and make it smaller, you can close altogether. So in the long run, average variable cost is the same as average total cost, because all costs can vary, right? They're all variable. So that means there's no such thing as an average variable cost curve. Everything is just up at that average total cost curve, right? The fixed costs don't go away, they just become variable. So if we're in that first region in the short term, this is where we had positive profits. This is going to attract people to the industry, right? If someone's looking at opening up a new business, and again, let's think back about planting crops. There's a lot of different crops that grow in a given region that require similar land and watering quality. And so based on the price of the crops the previous year and how much money was made on them, if they were a highly profitable crop, then people might switch to it. Think of ethanol. When ethanol became a popular gas source, more people started planting corn because you could sell your corn for more than you could before ethanol. So positive profits attract entrants into the industry. When that happens, that makes more people producing it, and therefore it increases the market supply curve. So as a quick little sketch here, if we have demand, market supply, your price, and then we get an increase in our supply curve, it shifts out like that, we see the price falls. So these positive profits attract new people into the market. That in turn increases the market supply curve and lowers the equilibrium price. So the profits come from having a price above what we called P3 in our previous graph, the 0 profit price. But as people enter, it pushes prices down. And so they'll stop entering once there's no profits to attract them. So they stop entering when they're at that 0 profit price. Okay. If instead people are in region 2 or 3, where they would be experiencing negative profits, right? So those lower prices have negative profits associated with them. And so if you're in the really low region, you're going to close immediately and leave the market immediately. If you're in the middle, you might operate for a short time, but as soon as that building lease comes up for renegotiation, you're going to try and get out of that contract because it's not going so well in that market. Or in this case, once the planting has already begun, you've kind of lost the money on the seed, so you might as well grow and do the crops, and next planting season you change what's in that field, right? So maybe not this planting season, but next one. So these negative profits cause producers to leave the industry. And when they leave the industry, it's going to decrease the supply curve. And so just a little sketch so you can see what happens when the supply curve decreases. That's an inward shift like this, and we see the market price rise. So the decrease in supply makes the equilibrium price higher. And so when you have losses because prices are really low, people will leave the market, pushing prices up. And it'll push prices up until there's no longer losses. So people will stop leaving again at the zero profit price. So ultimately, in the long run, because people can easily enter and exit in perfect competition, the long run equilibrium price is where the average total cost curve intersects the marginal cost curve. Right? We called that P3 in the previous graph, also the zero profit price. So what this means here is that there are no profits in the long run in perfect competition. Right? Because of ease of entry and exit, competition removes profits at some point. It may be fast, it may be slow, it depends on how long it takes for entry, how hard it is to enter, as well as how fixed those fixed costs are. So this might make you feel bad, especially since we've been talking about farmers. However, remember, when I say no profits, I'm talking no economic profits. So the farmers still make a living, they're still able to feed their family more than just the corn they grew, and take care of them and all of that. It's just saying they don't get extra above the time and effort, at least not for extended periods of time. To help you with the perfect competition class exercise, I'm going to run through what it is you'll need to do. So here I've changed the prices. The graph to the right, though, should look very much like yours if you chopped it off at $38 at the top. But otherwise it should look very close to the graph that you created, shape-wise. So first, if we're looking at a price of $30, you need to find where 30 is on your graph. On this one, it's this line right here that I can't draw straight. There we go. And our goal is to set price equal to marginal cost to figure out how many. So how many, we set price equal to marginal cost, which that is our blue line here, and that happens down at the very bottom, or our very uppermost point. So here our quantity is going to be 13 if they should produce. The next question helps answer whether they should produce. So it asks, what is the economic profit or loss? So for that, we're going to need to look at the total cost, or the average total cost as this one goes. That's the gray line in this picture. So average total cost here is $20. Or about $20. So for yours, you may want to look back at your table just to make sure you have the exact specific numbers that are correct for the prices that you're calculating, which again is not the same price that I'm doing here. And so will the firm earn a profit or a loss? Well, they're selling it for $30 each. It costs them about $20 each to produce it, so they're able to sell it for more than they can produce. So because their price is greater than the average total cost, they're earning a profit. They can sell it for more than it costs to produce each unit. So how much would the average approximate profit or loss be per unit? So since it asks for per unit, it's just asking for the difference between the price and the average total cost. So here, the price is $30, the average total cost is $20, and so the per unit profit is $10. Again, you may want to consult your table numbers to make sure you have as approximate of answers, or as correct of answers as possible. Mine are approximate here. So to figure out how much the profit or loss would be in total, this would be the per unit profit times the number of units. So we just found out that they're going to make $10 per unit, and a little bit ago we said they were going to make 13 units. So $10 for each of the 13 means they're making a $13 profit. Okay, or $130, excuse me. Forgot to multiply appropriately. So in this scenario, they're in a place where the price is pretty high relative to the costs, and therefore they are turning a profit. They're going to want to stay open and produce 13. Let's look at some other prices. Now let's investigate if the price was a little bit lower. Specifically, we're going to look at $9.50. So that's halfway between 9 and 10. So $9.50 is about here. Nope, got a little high at the end. But this is the unit that it goes to. And so that means they should produce 7 if they're going to stay open. Okay. We'll investigate more of the stay open as we get into the further questions. So again, to get how many you should produce, that's looking at your price equal to your marginal cost and see how many units that is. All right. So to figure out if they're having an economic profit or loss, we need to compare price to average total cost. So here at 7 units, we can trace that line back up and see that the cost is around $21. So you can sell it for $9.50, but it costs you $21 roughly to make it. Since it's costing you more than you can sell it for, you're operating at a loss because your price is less than your average total cost for your best number to produce, which is 7. So how much will the approximate profit or loss be? Okay. Again, we're looking per unit. So we need to compare and find price minus average total cost. So our price is roughly is $9.50. Our average total cost is about $21, and so that comes to negative $11.50. So that means either they're experiencing a loss of $11.50 or a profit of negative $11.50. So if you say the word loss, that means you don't need to also write the negative sign. They cancel each other out when you do that. So be sure to do one of the two and not both. Okay, so that's a per unit, but they've got 7 units that's happening for. That's $11.50 times 7 units. That's going to be 77 plus $3.50, negative $80.50. So they're losing $80.50 by producing these 7 units. So should they stay open or closed? Well, their options are to operate and lose $80.50, or to close and lose basically their fixed costs, which is $100. So because $100 is much worse to lose than $80.50, they're actually going to be better off operating. So even though they have negative profits, because they are able to cover all of their costs and pay off a little bit of their fixed costs, they're better off producing than if not. Last, we're going to look at what if the price is really low, $4. So in our graph, this line represents $4. If you're going to produce you would produce 5. In the low price that you have, there's 2 points that are $5. Either point will give you the same answer. Just I encourage people to use the higher quantity as opposed to the lower one, but it essentially doesn't matter. You're going to come to the same conclusion. So if they were to produce, they would produce 5. That's because that is where their price is equal to the marginal cost. They can't change their price, they just have to accept it, so they do the best they can given a price. So if they decide to produce 5, they would be at a place where their average total cost is roughly $26. So this means if they operate, they would have a loss. Specifically, the difference between $4 and $26, because it costs 26 and you can only sell it for 4, times the 5 units they would produce. So that's 22 times 5, which is 110. So if they close, then they still have to pay their fixed costs, but their fixed costs are 100. So would you rather lose $100 or 110? I'm hoping you said $100. That's exactly what the firm would say too. So they're going to close immediately. And that's because they're better off, since they can't sell their product for more than it costs to produce it. Right, if you look up here at the average variable cost, it's costing about $6 to make each of those yo-yos, and they can only sell them for 4, so they're losing $2 in raw materials and workers for each yo-yo they sell. So it's just a losing proposition, and so you're better off if you just close immediately, pay out your rent, and move on.